Time.
Mr. Olson.
Okay, game tomorrow. MCA. What's it over?
A1
through A4. Okay, so we are done with 8-5. There wasn't anything else to discuss on that. If you are running into questions on some of these things, ask during homework time. If you don't have time for homework time, check in and see if I'm available at lunchtime or something like that. So we are going on to 8-6. Maybe a 1 day, maybe a 2 day lesson. Not sure. We are looking at either testing on next Tuesday, because we'll do MCA on Friday. We will review Monday, test Tuesday, or pending, we may do a little bit more on Monday, review Tuesday, test Wednesday. So the test is either going to be on a Tuesday or a Wednesday of next week.
Mr. Olson.
What's wrong?
What do you think is the best, or like all-time best fast food restaurant?
We are not talking about that. Your notes are out. I'm about to write. You're about to write. I was going to say I'm writing, you're writing, except I'm not writing. So I can't quite say that. I'm about to write. You're about to write. How about that? What's wrong with you?
What is on your board?
Oh, that was for the sophomores. I think they were practicing dissection, and so they were practicing dissection. They really wanted me to hang the animals or the stuffed objects on It's not. I'm not into it. I was just trying to do it because I wanted to be like relevant to the students. And, so I don't know.
Hey, Miss Barnett was beefing with Arthur.
Okay, so dividing polynomials. Okay, so when we go to divide polynomials, let's go through a little basic review of division. If I said, let's go ahead and divide this. If I said 20 divided by 4, most of us know the mental math on that. 20 divided by 4, we would say is 5. Now, when we do that, you could set it up and say 4 goes into 25 times. 5 times 4 is 20. You subtract, you get out 0. And so you'd say remainder of 0. I'm not sure how you did it in elementary. Yeah. You might say remainder of 0 or something like that, or just have it as 5. What happens when I go 21 divided by 4 like this? Remainder of 1. So there was a couple ways that you did this. Possibly we would say 4 goes into 21 5 times. 5 times 4 is 20. You subtract, you get out the 1. You could try to do the decimal, like we could do that. Or you said remainder of 1. Or you wrote it as 5 plus the remainder over the divisor, which 5 plus 1/4, you could also write that as 5 1/4, like that, okay? And the reason why I show that is today we may end up writing some things like that, 5 plus the remainder over the divisor. Now, if it was all we were doing was doing this, you'd be golden. Maybe, some of you might struggle with it, I'm not sure, but you'd probably be okay. We're going to expand on this knowledge, okay? So the other thing is that what's actually happening up here, and I maybe should have shown it first, is when I have 20 divided by 4, isn't that the same thing as saying like 4 times 5 divided by 4? And you would say 4 and 4 cancel. That's also the case like that, right? And so you just have 5 like that. Okay. The other thing with the long division is let's do a little bit longer one with just a numerical setup, and let's go like 3,427 divided by, let's go with 6, something like that. So if we see division like that, let's just review long division, although we're going to be doing it with variables and a little more complex, but the same concept is going to apply. You would take 3,427, right? And you go, 6 goes into 34 how many times? 5 times. You would take the 5 times the 6, you get out 30, and you subtract, right? And you get out 4, right? And then you drop the 2 and you go 6 goes into 42. 7 times 6 is 42, and you subtract and you get out 0. You drop the 7. 6 goes into 7 how many times? Once. 1 times 6. And then what do? You subtract, and then you get out the 1. And so you could write this as 571 plus 1 6, or like we're comfortable with 571 and 1 6 like that. Okay? So, phew. That's long division, a little review of long division. We are going to apply these concepts to what happens when we're dividing with polynomials and variables and things like that. It's okay. Whew. What a journey. So now we're going to divide, or it's going to say find each quotient. What does a quotient mean? Quotient means you are dividing. And so you're going to have something like this. We'll call this number 1. You're going to have x cubed plus x squared minus x, all of that in parentheses. X cubed plus x squared minus x. And then it's going to have you divide by x. Now, they have it in a division format with the division symbol. They have it horizontally written. It doesn't matter how they have it written. You can adjust it. Probably what I would do here in this case is I would probably write this as x cubed plus x squared minus x divided by x. I'd probably write it like that for me. That's a little easier to see. Now with this one, we're not actually going to do long division. We are going to just understand that our value of x in the denominator is going to actually divide into, since this is attached with addition and subtraction, it has to divide into every single part. It cannot just go into x cubed. It's got to go into every single part. When you're teaching and you're just up here passionately like giving this lecture about, polynomial long division, and you're like trying to engage, and then you look out there and you got
Who's doing
That's Mac.
I'm so scared. I'm scared.
Okay.
I'm scared.
You can stop now.
Look away. I can do that.
I don't like
Can I
it.
watch it?
Attention time.
Oh, he's been hit with one of those.
I think just try doing that with somebody when they're sharing with you, when they're telling you about their life or something.
We should all do that.
Just now you working and you turn around.
I don't know what you should be doing. Keep doing that. It's funny.
We're just
It's what it gives me is job satisfaction that I'm doing a job well done.
Well done.
I'm making people's lives miserable. Check.
Check.
That's
That's my goal.
Math is important.
Okay, so here we go. X goes into, so we can do this mentally, just say x cubed divided by x squared divided by x divided by x, or we could take one step just to show it like this and say that divisor has to go into everything like this, and just write it that way. Most of us are going to be comfortable, I think, saying that x cubed over x, what does x cubed over x reduce to? X squared. X squared over x reduces to x, and then x divided by x is 1. Okay? And most of us are pretty comfortable doing like that. So the divisor has to go into everything. So that's what we would do on that one. What happens, let's expand our knowledge a little bit here. What happens when we have a little bit different formatting? We have 25ab cubed minus 35a all divided by 5a. Okay, so 25, that's an ab cubed, even if it's hard to see, it's a 25ab cubed minus 35a divided by 5a. What we know is that the 5a is going into, the divisor is going into a binomial. It cannot only go into one part of the binomial, it has to go into both. So if you need to, and it's helpful, please rewrite the problem. Don't be afraid to, rewrite it just like we did here. If you want to mentally go 5 goes into 25 5 times, 5 goes into 35 7 times, and then cancel out the a stuff, that's fine as well, it's great. But if you're struggling at all, just rewrite it, 25ab cubed over 5a minus 35a over 5a, and then simplify that way. So if we do that, we look 25 and 5, we already stated that was going to be 5. A and A, since it's attached with multiplication, we can cancel that out, right? So A divided by A is not 0, but
So it would just be
1. And what are we left with? B cubed. No, just B cubed, because B does not cancel with anything. And then on the right side, 35 divided by 5 is 7, like we stated, and A divided by A is 1. And so you just have negative 7, like that. And then that's as far as you can go. You can't combine. A lot of people end up combining, they feel like they need to keep going, but you can't, so don't. Okay? So there's that one. Then what happens when we get over into these things are too deep. I think they need to go. It's like, I don't know. It's too much, isn't it?
Yeah.
Enough of these.
It's kind of sad.
Do we want a challenging one? Let's do
No.
that one.
No, this is so hard.
7ab to the 5th. B squared c squared. What's wrong with you? I don't know. Somebody's complaining in the back. So.
That was not me.
That was not me.
That was Ethan.
Yeah, that was you.
Yeah, because you sometimes like Shiloh.
They're basically the same person.
What? Really? Oh,
It's so funny, I forgot to laugh.
That's not funny, Kater.
What did you even say? Oh.
That's really long.
What?
That's really long.
Are we doing it? No, we're not doing it.
Okay, go ahead. Simplify.
Oh, flip. This is good.
That was a good straight line.
What?
I don't know, I'm so happy.
We raised like jump to the machine.
Go ahead. Simplify. Divide. You quit.
Dave gave up.
If you need to rewrite it, rewrite it. Go ahead. If you want to.
Hey, you're no good.
How do you do it?
How do you do 7 divided by negative 2? 3 divided by It's not
Oh,
divided by.
That is
Awesome. I've given
Yeah,
up.
what?
I literally can't even read the answers.
Until it is the answer.
No.
Until it is the answer.
I said giving up is never the answer. Until it is the answer.
It
And then
is.
it's probably
It
true.
is always the answer. Because you can always give up, so. Actually, the answer is Jesus and
Can't
that.
drink stuff from a teacher.
Jesus is not always the answer.
Yeah.
What if you say,
I agree.
who caused the world to become trash? Then you can't say Jesus because Jesus didn't do that.
No, I'm talking about
Honestly,
in
what
like
the heck?
this. He's
Okay.
always the answer.
So, check with your support team around you. What did you guys get?
I got.
I don't have
Okay,
to.
hang on.
Oh.
Hang on.
I just know how to.
Take a deep breath.
Heck?
I can't breathe.
Is it that stressful?
Yeah, Avery, be my support.
My
My
support team. Here we go.
support.
All right, let's try this. Choco milk. Okay.
Are you gonna explain?
The building's
Okay, here we go. No, I'm not explaining anything with it.
What gives you sleep?
Now, we don't love 7 divided by negative 2 because it doesn't go into it evenly, but there's 2 routes to go. One route is you could go decimal and say negative 3.5, or they're going to leave it as a fraction. They're just going to say 7 divided by negative 2. They're going to just write it as negative 7 halves, like that. Now, typically with the negative, it's supposed to come out front. I have addressed this before. If you wrote negative 7 over 2, or if you wrote 7 over negative 2, I'm not marking you wrong. The optimum format would be you bring it out front though, like that, okay? So either any of those would work, but you usually bring it out front. Now, when you look at that, because remember, this whole thing divides into that monomial, this whole thing is divided by this, and this whole thing is divided by this. So now let's look at, we say, okay, this was 7 over negative 2. Whoops, I already erased that. let's deal with the A's and the B's and the C's. Oh, that was weird. Why did I have that?
I don't know. It made me mad.
Yeah.
I'm just kidding. Oh, you wrote it down wrong, I think.
Yeah, I
That's
think
fine.
I looked at the book in it.
No problem, we're gonna
My
leave it
answer
like
is-
that. We're gonna leave it like that.
Oh, sure.
okay.
So, we look at this, is there any A value here that's gonna cancel out with that? No, so we're gonna just leave that as A. Now, this is B to the 5th times B squared. It wasn't simplified yet, so really what would that be? B to the
Third.
7th, right?
Oh, I
So
thought
if
you were
there's
saying
B to the 5th times B squared, it would be B to the 7th. There's one B on the bottom, 7 B's on the top. How many B's are you going to be left with? 6. So B to the 6th. This is C squared over C squared. Those cancel to not 0, but 1. And so then we just don't write the number 1, though, right? We don't write times 1. Yeah.
How's it B to 6 good?
How?
Yeah.
Well, there's 7 B's right there.
Oh, that's in the same one. I didn't know.
And then there's 1 B here, so there's only 6 left because it's being divided. Now we have a negative and a negative. What is that going to do? Positive. 4 divided by 2 is 2. A, any A's to cancel? No, so A cubed stays. 1B and 1B cancels to 1. Again, we're not writing 1 because sometimes 1 stays the same, so we don't write that. It's excess notation. And then we look C, 4 C's on top, 2 C's on the bottom. How many C's?
C negative
C
1
squared.
Oh, it's
C to
the
the 4th.
Why did I put down the 4th?
Yeah, over C squared is C squared. Okay? Then we have a positive 3 divided by a negative 2. So positive divided by a negative is a negative. 3 divided by 2, again, we talked about this, it's just going to be left as 3 halves, like that, because it doesn't go into it evenly. Alright, and then the B and the B do what? Cancel. C to the 8th over C squared is
C to the 6th.
C to the 6th power. Nothing can be combined, so we leave it as.
Mr. Austin, I only messed up 3 times.
So,
I was so close. It was like the exponents, and then the last one I still put down the B because I forgot to cancel it.
Any progress, even in the wrong direction, is still progress.
Wrong direction.
Well, I mean, even if you got it wrong, it's still
Oh, yeah.
progress. Yeah,
Still
so-
progress. I'm still practicing. I'm out here working my butt off.
You're just cranking away.
I am.
amazing. And I haven't even had to say I'm writing, you're writing yet.
Oh, I haven't heard that.
That's why I'm working so hard.
Yeah, it's a new year, new you.
you haven't heard what?
New today, new today.
I'm writing
40
it.
days until you
What?
have to say it again.
40 days. Oh man, I look forward to
You
that.
just wait.
That is not what I got.
Idiot soup.
Okay.
Say idiot.
Now, this one is unique because no longer are we dividing by a monomial. The divisor is a binomial. So we're no longer dividing by a monomial, we're dividing by a binomial. Therefore, we have to do long division in this case. We do not take x minus 4 and send it into just the x and into just the 7x and then to the 12. Like we were doing with this monomial at the bottom, we can take it into individual parts. So this is going to be unique. We're going to set up a long division format, and we're going to take x minus 4 like this, and we're going to set up the long division format and say x squared minus 7x plus 12. Now it's really important here when you set it up, and they've already had it set up for you, is that it is in standard form, meaning x and then the constant out here in the divisor, and then x squared.
This is not.
And the facial expressions. X squared minus 7x plus 12, okay? So standard format in the divisor, standard format in the dividend, in the top part, like that. Okay, here's how we do it. We take when we look at these, we look at the very first term here, which is x, and we look at the very first term here is x squared. Don't worry about this for now. Don't worry about the other part for now. Okay, so you're just looking at the x and the x squared. you ask the question just like we did with the long division, which I've erased, but you said like 6 goes into 34 how many times, right? And then you said, oh, it goes into it this many times, and then you multiply that. So here you're going to say x goes into x squared how many times? Well, in other words, what times x, no, not twice, what times x gives you x squared? X. So what you're really asking is you're taking x squared divided by x, if you will. What's x squared divided by x give you?
X.
Is x. So that's the value that we put right here. You're asking what times x gives you x squared. Again, you're not worried about any of that right now. Okay, so once we establish that it's x, just like we did with the 6 goes into 34, 5 times 6, we now go x, and we're going to multiply it in. What's x times x? What do you get? X squared. And then we also have to distribute it into the negative 4. What's x times negative 4?
Negative 4x.
Negative 4x. Now, what we notice is that
Oh, again.
the first terms here in polynomial long division always should be the same. The first terms will always be the same. Second terms may or may not be the same. In this case, they're not. However, you'll notice the x squareds match, and then what else matches? The x's match. That's important for us. So what did we do in long division? We took 30, whatever, and erased it, you subtract. Okay, buddy.
Yeah.
Stop.
So.
You were doing so well. Just put it down. You subtract. Now when you subtract, you can't just subtract the first part, you have to subtract the entire thing. Your first terms always should cancel. What's x squared minus x squared? 0. So those always should cancel every time. Then you have negative 7x. It's not minus, because what do you have to do? You have to distribute that negative in. So in this case, it's negative 7x, and a negative will be a positive. So it's 7x plus 4x, which is a negative 3x. Then just like in long division, you drop your next term, right? So what do we do with the 12?
Bring down the 12.
Bring down the 12, and it is what? Plus 12. Then, just like in long division, you looked and said like 6 went into whatever value that was, right? So now we're going to say, we're going to look at just our first term and our first term again. What times x gives me negative 3x? Negative 3. Okay, so again, to get to negative 3, you're saying what times this value gets me to this value? Or you can take negative 3x divided by x, those cancel, right? And you're just left with negative 3. That's where we're getting that negative 3. We then take, what are we going to do with the negative 3? Are we going to only multiply it by the x? No, we're going to distribute it in. So what do we get? A negative 3x, and then a negative 3 and a negative 4 gives me plus 12. Your first terms will always match if you did it correctly. Your second term may or may not match. In this case, they do. But your first term always matches. When I go here, what do I need to do? Subtract. Am I subtracting just the first one?
No.
Whole thing, so I put parentheses. Something you could do if you want, you could do this, like I showed the parentheses, you're subtracting it. You could say, well, I know that when I subtract, what happens to my signs? They switch. So I could go plus and minus. That's something you could do too, so that you visually see that. That's acceptable as well. But make sure you change both signs. If you change both signs, what happens here in this case? Works out really nice. Gown and gown. What's our value? 0. So what's your remainder?
X minus 3.
Well, your remainder is 0, right? So what is your answer? What's your quotient? X minus 3.
That was actually surprisingly easy.
It's not too bad. It's just you have to just follow the pattern.
Why wouldn't it be x minus 3x?
Yeah,
X minus 3. So what you are finding is it's just like this. Like think about this. 20 divided by 4, right? 4 went into 20 how many times? 5. So what you're finding is that 5 times 4 gives you 20, like going backwards, right? So in this case, this value divided by x minus 4 gives you x minus 3. So what you're finding is that in this case, x minus 3 times x minus 4, guess what it's going to give you? That value right there. So if you FOILed this out, x and x is x squared, negative 4x minus 3x
I see.
plus 12, x squared minus 7x plus 12. So we have there. Okay, so tomorrow, what are we going over? MCA! 8-1 through what? 8-4. I will let you know tomorrow about when the test will be. I'll give you the formal. I'm going to look at it. Short?
Yeah, that's like